Thank you. So it's not going to be a gardening session, as you might expect maybe, but in a way, maintaining an open source software project is a little bit like gardening, especially if you step away for a few months and then come back and it's all overgrown and issues pile up and depend a bot. Yeah. Depending on your language, this can be a problem or it isn't. But I also have an alternative title for this session, which is kind of harnessing contradictions in a gist. And I will get back to what those contradictions are, but just keep this in mind. And I also have to warn you before, this is all going to be a little bit meandering. And because for me, like my biggest struggle with those kind of talks is that you have 40 minutes to compress 20-something years of work. And it's almost, after a while, becoming impossible for me. I see this stuff more like a tissue which has grown together and where everything depends on each other, more or less. And then kind of trying to rip out a single linear thread of storytelling is almost near impossible. So please forgive me if it goes a little bit through the vegetable garden. So yeah, my name's Karsten Schmidt. So I'm at the moment, for the last year, an independent software engineer or whatever, developer. And since basically the beginning of 2000s, early 2000s, I've been mainly focused on like computational design. So basically trying to solve design problems, whatever they might be, and I will give you examples later, through the lens of software engineering, and also how we approach kind of general, how we plan software, but apply it in a design or architecture or product design or art context. So that takes many different forms. And everything I've done really basically throughout my career, or anything notable really, is open source based. And yeah, on the right you can find my different various Twitter handles and my website, but that's not now important. So as I said, like most of the stuff is really about generative design in the widest sense. So these days, like the term generative is kind of shape-shifting all the time what people understand under it. Like 10 years ago, we had a much more clear description what it means than what is now being like publicized in the media. But you could kind of impose a hierarchy saying computational is everything where you use computational means. Generative is something where you have an autonomous system creating something which generates. And then procedural would be more where you have like a fixed procedure where you plug in different parameters and it's more or less just variations on a theme. And evolutionary is, as the name implies, Darwin and friends. As a fundamental mechanism. So, but I'm now not going here through it too much because I haven't got much time. But one of my guiding quotes, and also second warning, there will be lots of quotes because I always think they help much more to kind of frame, and people are much clever than me to put things in perspective. But this Wittgenstein quote really is one which has been guiding me throughout all those years. And especially when it comes to programming, I think I've also noticed this on Friday. We always, when we talk about programming or when we meet and talk about programming or software, it often either the discussion goes about expressiveness or performance. And there doesn't seem to be anything in between really often. I mean, I'm super simplifying here, but this has been my experience. And throughout the years, I've kind of had to deal with those languages. And starting really with, this is more or less in a chronological order. So I kind of started at the bottom end in assembly on East German hardware. And then kind of over the next 10, 15 years, worked my way up to Lisp, where I basically, if you see this as like the tower of abstraction, you can't go much higher. And for the last, don't know, like 7, 8 years, I'm on my way back down into the basement. So, and I will get back to this point later, but I just want to frame a little bit so you understand more where some of that other stuff comes from. If I look at all those different languages, and these are only the most important ones, the ones really which stuck with me and which kind of helped me like think about programming more, and especially also this how to solve generative design tasks or how to approach them, really has been those highlighted ones. But as I said earlier, often when it comes to talking about different languages, we also often really identify ourselves as communities, not on the topics we are dealing with, but more on the languages we are using. So we have like this amazing SIG community, which is growing, but we also have a TypeScript community, we have a Clojure community, and all of those are more or less pits, sorry to say so, but there is not much cross-fertilization going on, and that's why I also used that kind of vegetation slide in the beginning, because I really see this much more by not being really fixed part of those different communities, and not because I don't want to, I just often find it too insular. I really hope that we at some point get away from identifying ourselves as like, I'm a SIG user, I'm a Java user, I'm a PHP user, and then getting kind of belittled from the outside if you are not part of that camp, that it becomes more of a cross-fertilization community. And also here to keep in mind, what we have at the moment is essentially this. We live in this Tower of Babel. We had this kind of explosion of languages in the last 20 years, new languages, which are all really great and also very much needed to move our field forward, but we have the same problem what's described in that story. So I really think we need less attention economy, where all those languages kind of argue and want our all core attention all the time. And like Rust is better than this, or C is better than C++, or all of those languages in a way exist because they found a niche. They found a niche in our way how we think about technology and how we think about computing, and those niches simply exist. This is what the presence of those languages shows. And what is maybe more needed is more people who kind of navigate around those and kind of just go on a hike, more or less, through that landscape of what those different languages actually offer conceptually, because each one has something to offer. And what I think is really missing, in my opinion, very humble opinion, is someone who goes more exploring and kind of starts collecting and harvesting concepts, and then apply them as well. Because as we are still in this world where we have basically like in the 80s, where you either belong to the Atari camp or the Commodore camp. I don't know who is old enough to remember those times. Yeah, I'm sure there are a few more. So, and then there are also here, I told you there will be quotes. Like Alan Perlis is probably the purveyor of the best programming quotes ever. You should really just check him out if you don't know him. Is highly entertaining. And then also the author of the C++, STL, or one of the main authors. And I think that quote really struck a chord with me, and not just with me, I also know many other people who, when they first read this, went like, huh. Like, I really think for me, this is, after I spent 6-7 years working in Clojure and ClojureScript, and like at this really had an amazing time, unlearned everything I learned in Java before, and it has really changed the way I approach programming. But when I read this quote, it really kind of hit hard. And I really think there is something here. This is how I started, East German hardware, what I mentioned earlier. I don't expect anyone to know that. I also wrote about all this, what I just mentioned, a really long article, like 20-minute read or so. If you want to check this out, this is the URL. That's from 2015 already. And also just to frame some more why I think this journey from, mine's not playing, because, yeah, unfortunately, those videos I don't have online, offline backup. Okay. These are some scans from my Atari time, how I started with a here hand-typed opcode table for the 6502, and then going on basically programming with pen and paper because we only had 1 hour of computer time a week. And this is where you then basically had to hand compile the assembly into hex code, and then you typed in the hex code in that 1 hour, and it either worked or not. And if it didn't work, you went again the next week. So, and this is how we learned basic programming. It was me and a bunch of other 13-year-olds, 14-year-olds at the time. And back then, because we had nothing which came with that hardware really, apart from there was a basic interpreter and there were a bunch of games, but they were super boring. So what we really did in that first year was learning how to basically code assembly and start making our own tools and everything related to it. So we made icons, fonts, learned about dithering. Here, these are a bunch of icons for a paint program I did later on the Atari, then after the war came down. Here are some game maps for games I made, like just, what is the genre called now these days? Roguelikes. Sorry, I'm too, back then they didn't have a name, or a genre name. Yeah, so, and then also did my first 3D graphics in like the 90s, which was without cosine and sine, very hard to do. So I'm trying to paint a little picture that things we take for granted now in almost every language back then had to be kind of based on a complete culture of improvisation and kind of self-guided research. All the things what is kind of taken away these days for novices who are coming into programming. These days we have tools like processing and other like kind of tools which are aimed at non-programmers to introduce them to the idea of coding, and they are getting amazing results in no time. But my criticism of that is that there's also not enough knowledge being kind of communicated, which actually helps those people then really getting the basics of how certain techniques work fundamentally. And I always think if you really want to innovate in any field, you need to understand how the thing works underneath the hood, to some extent at least. Sorry, what is this now? I'm not prepared.
Can't you pause it and play again?
Yeah.
Make it pause and play again?
No, you can't really. It's in Google Slides.
Can you click on pause?
Okay.
And then play?
I'm sorry. It's a guy. This is just like a Lemmings clone I wrote in the 90s. Doesn't matter now. Sorry. You all. Do you want to see it? Then.
I love Lemmings. Who has played Lemmings when? Yeah.
So let's see. There's here a nice, cute. So this year, Chip Special Software was my first company. Oh, what is happening?
It is buffering but not playing.
Yes, I have no idea why. So I can only jump through here. So this is the title screen. And I did this when I was doing my A-levels, 4 hours before school, and then 4 hours, 5 hours after school every day for 8 months. But that was my first job, and apparently it was one of the best-selling games on the Atari in the early 90s, like the 8-bit Atari. Like there was obviously already a proper Lemmings version, but only for other platforms. Anyway, what I'm trying to get to here is this. So this culture of building your own tools was really with me from the beginning, and it's also, this is not my quote obviously here, and it's also that quote itself has been attributed to many different people. I'm not entirely sure if this is the original author. It has been attributed to Churchill as well, so go figure. But I really think building your software, or when we talk about also what you mentioned earlier, Loris, when it comes to moving our field forward, you can either apply the Silicon Valley way, where you create a market for something and you create a demand, and often those things are only really done for a quick exit, and then those ideas die quite quickly often. And the other way, maybe on the other extreme, there's obviously a big valley in between those extremes, is that we build software more in a way, the original meaning of personal computing, where we have a market of 1 or maybe 10 or maybe 100, but something really small and controllable. And we start really building for those existing demands of what people have, just like we have done before computing. If you think most tools we are having in the physical world around us are the result of improvised kind of tool making for a concrete need someone had in the real world, either be it something to create or to destroy, or there was always some form of concrete need, rather than something which is artificially created. And I think this is really what is kind of guiding me all those years in building this thing, which is really called Thing. So this is actually, I'm not expecting you to read it, but it says, it does say Thing, and it is also the URL. So Nigerian spam filters will catch me all the time. So probably do, because I'm not getting many PRs. So here are some, those stats are slightly out of date, but they are from roughly like 2 weeks ago or a week ago, something like this. But I'm working on this project basically almost every single day for the last, in its various manifestations since roughly 2005. So, and this is not a single project for a single language. It has shape-shifted from Java, where it originally was called Toxiclips, and it was also already a bunch of different libraries. Toxiclips because my nickname is Toxi. So, and then I did, as I said earlier, around 6-7 years of closure. So I started adding new libraries for closures, because these were new languages, just like SIG is now, which is my next goal. But every time I encounter a new language which I think is really contributing something new to the world, a new way of approaching things, a new opinion on how to solve problems, or a new kind of catapulting us up to a new layer of, or new level of how we can express and communicate with machines, then I'm trying to kind of combine this with my existing knowledge and tools. And basically over the years, this project became really I hate the term, but it's the best term there is at the moment, as far as I know, polyglot. So I know a lot of people just like go like, but I'm also not have to say, like, even though this is addressing different languages over time, I'm a one-man show largely. Like I'm saying here, I have 33 contributors, but it's really 99% just on my shoulders, most of this stuff, unfortunately. And yeah. So I will quickly leave this presentation here just to quickly show you the website. So, and here's also to give you a little bit of an idea. This is a tech cloud. So this entire website is not super informative, I've been told. There's a whole Hacker News thing about it, how uninformative it is. But this tech cloud is kind of giving you an idea, at least a visual idea, of the different types of topics which are covered. So we can just here randomly zoom in to, oh come on, what happened here? I think my little MacBook is over. You can also do fuzzy search if this thing wakes up. I really have no idea why this is. It's completely frozen. Why? What would the mirroring?
Could be.
Yeah, anyway, so there's a tech cloud, and then there's also here a timeline which is just documenting the commit history of all the different TypeScript packages, which is my main target at the moment. I will explain this a bit later. So there are about 170 of them. And then, if this catches up, down here you also, sorry about that. Down here we have also a timeline of the last, basically since 2005, of all the different projects created under this banner. And each of them you can just click on it. For instance, Resonate Workshop 2015, and you go to the repository, and most of that stuff is basically open source and on GitHub with very few exceptions. And I just quickly wanted to show that. And let's go back to the other tab. And here is, so one of the big things I like to do, because for my own benefit, you already saw it's a pretty vast scope. And often the way I develop those different sub-projects, and altogether over 100,000 lines of code, I have to develop them in a more or less round-robin manner. And basically, I sometimes might only come back to a project after half a year or maybe even longer. So what really helps me is to have lots of visualizations of the different structures. So here, for instance, this is a map of this older Java library showing all the different classes and how they are related to each other. And here we also have, to just give you more of an idea, we can't do videos, it seems.
Can you try reloading the presentation tab entirely?
Yeah, so let me just, page 29. I have no idea why it's so bad. Mm-hmm. I was hoping I set the whole thing offline, Google Slides, but it doesn't obviously download videos. So,
try now.
Yeah. No.
No. Sorry.
I don't know. I'm really sorry. Yeah, that would have been a nice show reel of basically. In 2009 and 10, I did those community show reels where I asked different people who use all those libraries to contribute their projects. I might actually have a local version. Give me just 1 second, please. Do we have time still?
Yeah, for sure.
Let's try this one more time. Yes.
Yeah.
So as I said earlier, or tried, maybe it wasn't quite clear. So this is a community show reel I did where about 20 different people, or 15 different people back then in the first year, contributed their works, what they are building with those code libraries. So just to get an idea what we are actually talking about. So that, as you saw, that goes from physical fabrication here, 3D printing, or physics simulations here. That shows the breakup of the empires in some fluid simulations. And basically what the library, and here in the overlays you can also see the different packages which were used for those individual projects. So here's some physics-based typography, and then like exporting it as 3D meshes and then taking it into an external application. Yeah. That was my first 3D printing project. If we have time, I will talk about this some more later. Then voxel modeling before Minecraft. So, and that's, for instance, one of the things which I've kind of, this topic, voxel modeling, I've kind of been coming back to over now 20 years, really, every time iterating on that theme. That was an installation for Nokia at Terminal 5 in Heathrow, where they had those big various data visualization projects by other people. That's from a workshop in Portugal. That's people saying good morning on Twitter, and the color is showing the time of day locally, so you can see early risers and late risers. These are all projects by J.R. Thorpe, a Canadian data visualization designer. That was an interactive installation and also festival identity in London for 1.0. I worked on wind tunnel simulation for Audi. That was for a TV advert in Australia. And it's basically really all of those different projects are built with those open source tools. So some of those projects only came to me because commercial design studios couldn't handle this at that time, because commercial design software didn't have support for certain simulations, for instance. And yeah, so there was, and I will talk about this part as well, because I think this is really important if we, like, if this is here about knowledge sharing and kind of growing an ecosystem of more open source tools. How do you fund stuff like this? But before we get there, is Ivan Illich always has a good thing to say about the current state of software, even though he never experienced really those issues we are dealing with at the moment. But this again, what I talked about earlier, like the kind of difference between Silicon Valley and a more kind of the homemade or handmade approach to kind of cottage industry style software engineering. So I will get to this a bit later. I mean, this is also very fitting, I think, for SIG. I might leave this up here for a second. And the part of the SIG then about not hide or being explicit about control flow or about everything really, including allocation. I think there's too much magic, back to your point, in modern software where people have all those zero config things which do everything, and no one understands when they break what has broken and how to fix it. It's a big issue, I think. But as I just hinted at, like, how do you, like, with those kind of projects, so they are developed over a number of years, in this case here, over 20 years now, or close to 20 years in the current form. There were other open source projects before, I'm not going to talk now about. But how do you fund it? So for the longest time, I basically I did those commercial commissions for those different clients, and also did toward workshops. And this kind of paid the bills, but it's not, in a way, the only way this was funding the open source work is that I basically branched off income, which I got from those projects, and then kind of did all the open source maintenance on top. And obviously, as we all know, those kind of things are not sustainable in the long run. And that has been problematic, but and that also kind of forced me in the end to take a full-time job at some point, because it wasn't really that sustainable in the long run. But these days, last year I've tried out, and now please don't laugh, because this topic is like Marmite. Does anyone know what Marmite is? No. Yes. So Marmite is this, is it British? Yes. In Australia it's called Vegemite, same thing. So you either hate it or you love it. There's no middle path. There simply doesn't exist. And the same thing goes with NFT. But I'm always trying to give the benefit of doubt to new things, because new needs friends. Who has seen Pixar, Ratatouille? Yeah, new needs friends. Anton Ego. And basically what I tried to do last year, and I think successfully, was to create a series of generative art projects and use those sales as NFT sales to kind of fund the next few years of open source development for myself. And we can very quickly look at them. Maybe not this one, let's use one. There are a bunch of ones. For instance, this one was the first one where I did another experiment as part of this, because this entire project is built in SIG as well. So if we go quickly to quasi-flock, I think that should work, yes. So this redirects to FX Hash, which is this NFT marketplace where you can publish your generative design projects. And the way this works is that you say how many editions you want. In this case, I can't remember how many. It should say somewhere. I think over 320. So there are 320 different versions. They are all not super different, but they are different enough. And there should be thumbnails loading. I don't know again, why not? But let's just open this up so you can see the real-time version. And that's also interactive. So this was so that's obviously SIG running in the browser with a bunch of my own Thing umbrella libraries, for instance, for doing the WebGL interoperation. And that actually runs faster. It's very slow now because of the video mirroring that runs actually like butter smooth at 60 frames per second with no issue. And yeah, so that was my first kind of real world trial to kind of combine my existing library ecosystem with now a new language. And since this project, this project launched in January, and this year my main focus really has been to kind of work on this interop layer between not just SIG, but any language which can compile to WebAssembly and the kind of JavaScript world, so you can run things in the browser. And we have now a kind of general bridge already, which can basically it just provides a very basic core API, mainly for debugging and memory access, and also memory allocator handling, and then also clean up from JavaScript side and vice versa. But then you have, for instance, now a DOM module where you can manipulate, for instance, the browser DOM. I can very quickly show this as well, since we are here. Yeah, this is a very small drawing up, which is also written in SIG, and entire, like the canvas and those buttons and everything is created from the SIG side. And it's super tiny. It's like 8 kilobytes or something like this. And then here you get then also the logging stuff here when you're setting up event listeners and allocating memory and blah, blah, blah. We can talk about this later. I digress, as usual. But I maybe have something more to say about this, because the nice thing about this NFT mechanism is that there really by now is an audience for this kind of work. And even though it doesn't finance the open source development directly. It is more closer related and more closer as a funding mechanism than going out and doing client work, spending a fixed amount of time or budget to do that project, but then actually just take the scraps which are left over and kind of have this flow back to open source. My next project I will release over this system will also then you can do royalty sharing, where you say you give X% of all income to, for instance, another account, which could be, for instance, the SIG Software Foundation. So that could actually be used not just to fund a single project like my stuff, but it can also then, depending on who else is involved, kind of branch out. And the other nice thing is, when those pieces are resold on the market, if they are resold, that's a big question, but this income can be split perpetually. So as long as that blockchain, whatever, it doesn't really matter now, in this case this is Tezos, but there could be other ones, like if you use Ethereum, whatever, they can all be set up in that way that there can be a perpetual revenue split, and that would mean potentially constant, even if it's small amounts of income. Could be interesting, and I think more people should explore that stuff rather than just ditching it. But again, I'm also still to some extent on the fence, so I'm not NFT fanboy as you might think. So I don't know how we are doing with time. I think I have to, unfortunately, I mean, these are other projects I wanted to still talk about. I can quickly, maybe, how many more minutes?
Let's say
2 more? Yeah, okay, 5 more. This just to kind of, let me skip this one, even though it was interesting. Yeah, this, I mean, very quickly. This is a language I designed, which is completely like a super small language, completely functional, only has 8 verbs. If you think about a function is an action, is a verb. Yeah? Like Java is a kingdom of nouns, as we all know, since Steve Jackie, or whatever you pronounce him, Steve Jackie.
I'm the wrong person.
Famous Java programmer. And yeah, he wrote this amazing essay, like, don't know, 15 years ago, how everything in Java is a noun, and even verbs are turned into nouns, and what world that creates. And in Lisp, everything is a function, so it's the complete opposite. So there are no nouns, and therefore no things, so everything just becomes a recursive action, which is quite interesting to think about. And if you just have those 8 verbs, which are visualized here, so for instance, splitting something, or insetting something, or splitting something the other way, or mirroring, or scaling, tilting, or the very right one is deleting. And if you combine this and apply it to a single seed shape, in this case, the seed shape here is my mouse visible? Yes. So the seed shape is one segment of this hexagon here, which is basically just an excerpt from a circle. And if we only use the rotation verb, we can rotate that segment multiple times in different axes, and it forms in 2D this infinite grid. So this would continue forever. I'm just terminating the recursion. But if you change the seed shape and you use the same process, but you now take an excerpt from a sphere, not a circle, now we are in 3D, then that entire process starts curving up and creates this hemisphere. And there's no other change apart from the seed shape. And this is an extremely powerful way of modeling and also thinking about objects in the real world as just basically structures of code. And what you can then also do is you can transplant a branch of an operator tree from one object and transplant it onto another. And this is what I did in this example here, where you then get those antennas on top of every of the segments. And here you can see this whole thing growing as well. Again, this is terminated after, I think in this case, 60, 70 iterations or so. But you could continue this. And if you think about combining this with a kind of genetic algorithm or machine learning these days, which is all the hype, then you can really have a bunch of prototype trees and you randomly combine them and you have some form of fitness function and you evaluate what is maybe like a more optimal solution for a physical object. For instance, a lot of the turbine wings for ships, they are designed with usually with an evolutionary algorithm, because they are too hard to design those curves by hand. And then the other nice thing is, again, back to the visualization part, you can take those structures which are code generated themselves and visualize them, and you can then also kind of, even though you can't really read labels here, you can see from the previous structure here how some of those structures also in an abstract way repeat. Yeah? It's quite interesting, I thought. That was another project. I really have to now jump through here. There was one more behind. That's here. So this is just again, similar to the previous one, where we use a generative and also an evolutionary approach to design computer vision markers, which can then be printed out and attached to physical objects. So this was done. There was an Austrian guy called Martin Kaltenbrunner who designed or developed a tool called Reactive Vision around 2005-06. And he also had the startup, which you might know, which called React Table, where you had like an interactive table and you could put physical objects on to make music collaboratively and like have different synthesizer operators. And it was all driven by markers like this. And the whole thing was open source, but the problem was it only had a small library of, I think, a few dozen objects you could identify. And I then developed this project to basically have infinite numbers of them. And the really nice thing is, on this, also going back to software we can love, a lot of it is about interaction design, and what often really we want is how the interface should become almost like hidden completely. And I was involved in this company I worked on, like moving brands in London, where we developed those interactive tables for the fashion, London College of Fashion and their final year shows. And we basically had for all their students those individual cards, and people just collected them from shelves, put them on the table, and then you can use the rotation of the card, because you can see here there's this green arrow. It actually, the marker encodes direction. You can use this as an input mechanism. So you have position and you have orientation. So it's actually a 3D controller. It's more powerful than your mouse, those symbols. And you can, you don't need any other interface. You just card on the table, thing appears, and even little kids were very happily using it. That's maybe we can stop after this. Such a shame with that video. So that's just a very brief impression. So here you can see how people collect those student portfolios, basically business cards, and then when you place them on the table, their entire portfolio opens on the card, and then you can fan through it. And this kind of project and this approach that's continued for 5-6 years, where I worked on different iterations for different clients, and that finally culminated in the Google Chrome Web Lab exhibition at the London Science Museum. where I designed this marker system you see here. And each of those cards were handed out to over 400,000 visitors we had. That was in 2012, the year of the Olympics, so there were lots of visitors in London. And each visitor basically gets one of those tags, and then they can walk through the exhibition and check them in. I had to write this decoder as well. This is me, bad hair day, 2011 or 12, something like that. Yeah, that's what 10 years do to you. But here you can see, like this, I think was the Flash version. So as I said, I had to write a Flash version, OpenCV, C++ version, a GLSL version. They were like I had to redo this project several times, but the idea is all the same, that the system recognizes physical objects and then can respond to it. And this is just a few more images and then I'm done. Here you can see the dispenser where people picked up those cards, and my main project was this wall here, which I basically consulted on in two parts. There's this robot arm which actually draws with pen on the glass wall, and then my part had to do with having all those visitor symbols floating in that space but being aware of the physical drawings. In this case here, the map of Australia, where those symbols can't come out. They are really physical obstacles for the simulation temporarily. And yeah, I think this is really it. I could talk about this stuff for hours, and I have hours more to show, but it's not my conference. Yeah, we can. Just wanted to show the animation briefly. I will jump to the end, so you can take a picture of this if you want.